Hello viewers, welcome once again to Esomnofu online math class. Today we are going to discuss the modulus and direction cosines of vectors in two dimensions. If this is your first time of viewing, consider subscribing to my channel to be always be updated whenever I upload a new content. Okay, now we are talking about two dimensions, and two dimensions you can only have x and y values, but for three dimensions you can have x, y, and z. So, but today we are focusing on the modulus and direction cosines of vectors in two dimensions. And I want you to also note that the modulus of a vector is just the size of the vector, the magnitude. So when you hear modulus, just know that it can be known as the modulus, the magnitude of the vector. So when you have vector x and y here, the resultant, according to triangle law of vector addition, is this particular place. So the magnitude of this vector is the sum of squares of these two vectors, even according to Pythagoras theory. So the modulus of r, written as this is how you write it. Modulus of r is equivalent to x squared plus y squared. Okay. Now, modulus of r staying alone will now be equal to the square root when you take the square root of both sides of x squared plus y squared. So this is the formula we use in getting the modulus of a vector. But what about direction cosines? Let's assume that here is alpha and the angle here is beta, for instance. Direction cosines, so we shall focus on cosines only. That's why direction cosines. Okay, now when I talk about cos alpha, for instance, here, cosine is adjacent over hypotenuse. So cos alpha will give me my adjacent is equal to x. Remember, the side facing the angle is the opposite. The longest side is the hypotenuse, while here is the adjacent, okay? So cos alpha will now be adjacent, which is x, over hypotenuse, which is the modulus of r. So I can write that my cos alpha is now x over the modulus, and modulus is just the square root of x squared plus y squared. So this can serve as the direction cosine for cos alpha. What if I want to get the beta? Cos beta this time around will be still adjacent over hypotenuse. But when I'm talking about beta, here becomes the opposite to beta because this side is facing it. Then here turns to be the adjacent to the angle here. So my adjacent is now y over hypotenuse, which is modulus of r. Hence, cos beta will be y over square root of x squared plus y squared. So this is the formula you use in getting cos beta, and this is the formula you use in getting cos alpha. This is also the formula we use to solve whenever you are asked to get the direction cosines. So we are going to take some programs to make you understand actually what these modulus and direction cosines are all about. Right, so we have this question at hand where we are asked to find the modulus of the following. The first one is 3i plus 4j. We have I minus 3j and I sine theta minus j cos theta. We are asked to find the modulus of these given vectors. So here is the solution. For the first one, I have 3i plus 4j. Here my x is just 3 and my y is 4. Okay. Now the modulus of the vector, let's say this vector is equal to r 3i plus 4j. Let me assume that this is the vector in question. So that modulus of r will now be square root of x squared plus y squared. Hence, modulus of r is equivalent to the square root of 3 squared plus 4 squared. Okay, so from here I'll have that the modulus of r is equivalent to square root of 3 squared is 9 plus 4 squared is 16. So modulus of r will give me square root of 25, and square root of 25 is just 5 units. So the modulus or magnitude of this vector in question is just 5 units. Okay, so let's take the second one. For the second one, we have I minus 3j. Here, x is equal to coefficient of I is just 1, and coefficient of j is minus 3. Okay, So let me assume that R2 is equal to I minus 3j. The modulus of this vector is equal to R2. So the modulus of R2 will give me square root of x squared plus y squared. That's the formula. So this is y. So now modulus of R2 will now be the square root of x is 1. So I have 1 squared plus y is minus 3 all squared. So modulus of r squared will give me square root of 1 squared is 1 minus 3 squared will give me positive 9. So modulus of r2 will give me square root of 10 units, which if you like you can use calculator to find the value of square root of 10, but it's not necessary. Okay, the third one we have, let's say r3 equals I sine theta minus j cos theta From this, my x equals sine theta, because sine theta is just the coefficient of I here. Then my y will be is negative cos theta. When you know that the modulus of r3 will be square root of x squared plus y squared, so modulus of r3 is now equivalent to square root of x is sine square theta when I square plus y is minus cos square theta, and when I square this I have square root of sine square theta plus cos square theta, because squaring this negative sign goes away. Cos theta times cos theta will give us positive cos theta. Okay, let me clear here and continue. But there is a trigonometric identity that told us that sine square theta plus cos square theta is equivalent to 1. You should know this. Hence, we have that modulus of r3 is the same thing as square root of 1, because everything here we turn into 1. Cos square theta plus sine square theta is 1. So the modulus of r3 will give me square root of 1, which is still 1 unit. So you've now seen how to find the modulus of a vector. So let us proceed to see if we can get the modulus and the direction cosines of vectors at the same time. Okay, look at the question we have here. We are asked to find the modulus and direction cosines of r1 plus r2 and r2 minus r1, given that r1 is 7i plus 3j and r2 is 2i plus 5j. All right, to do that, you have to note down the following. That the first thing you do for number 1, where you have r1 plus r2, means adding r1 and r2. This is the same thing as 7i plus 3j plus 2i plus 5j. That's just it. So we need to add up. When I add up together, you have to collect like terms. 7i plus 2i will give us 9i. 3i plus 5i will give us 8j. So 3j plus 5j will give us 8j. You see how I arrange it accordingly. Okay, now we've found r1 plus r2. Then let us get the modulus, because they talked about modulus and direction cosine. So modulus of r1 plus r2 is something as square root of x squared plus y squared. And my x is equal to 9 this time around, and my y is equal to 8. So I'm going to plug them in here to get the required value. So now, modulus of r1 plus r2 will now give me square root of x squared is now 9 squared plus y squared will be 8 squared. So this will give me square root of 9 squared is 81, and 8 squared is 64. So modulus of r1 plus r2 will give me square root of 145. When I add together, I'm getting 145. Okay, now in short form, let's see if we can split this in short form. Let's divide 145 by 9 and see what we can get. 9 here is 1, remainder 4, remainder 5. and 9 cannot go, but 3 can go, 3 cannot go, nothing can divide. So 145, can it be split? If I divide by 5, let's see. If I divide 145 by 5, I'm getting 29. So it cannot go. So let's leave it as 145 as the required modulus. Okay, now we are also asked to get the direction cosines. Remember that cos alpha is equal to x over modulus of R1 plus R2 this time around, because of course it's supposed to be just modulus of R, but this time around, look at what you're having here. Okay, and the cos beta will be the same thing as y over R1 plus R2. Okay, so now my cos alpha will be x. My x here is just like 9. Okay, so it will give me 9 over, this value gave me 145, so it will be this over 145. That's just the answer. For cos beta, it will be y, and my y is 8, as you can see. So this will give me 8 over square root of 145. So this is the direction cosine. So therefore, cos alpha is 9 over sod 145, and the cos beta is 8 over sod 145. These are the direction cosines. Okay, let's go to the second one where we have R2 minus R. So for the second one, we have R2 minus R1, and the R2 is this. My R2 is 2i plus 5j minus R1, which is 7i plus 3j. The negative affects everything in the bracket, so we have that R2 minus R1 will give us 2i plus 5j minus 7i minus 3j. So we collect like terms. R2 minus R1 will give us 2i minus 7i is minus 5i. 5j minus 3j will give us plus 2j. That's just it. So here, our x is negative 5 and our y is just 2. That's the value. Hence, the modulus, let's get the modulus first. Modulus of R2 minus R1 will be square root of x squared, which is minus 5 squared, plus y squared, which is 2 squared. So modulus of R2 minus R1 will give me square root of 25 plus 4. And 25 plus 4 will give me 29. This is just the modulus of R2 minus R1. So let us get the direction cosines. Direction cosines, which are cos alpha, will be x over modulus of R2 minus R1. This will give me, my x is now minus 5 over square root of 29. Y cos beta is just y over modulus of R2 minus R1. And my y is just 2 to give me 2 over sod 29. Therefore, the direction cosines are cos alpha, which is negative 5 over root 29, and cos beta, which is just 2 over sod 29. So you've now seen how to find the modulus and direction cosines of vectors in 2 dimensions. If you've enjoyed what you've watched, kindly consider subscribing to my channel. It will make you to be notified whenever a new content is uploaded. Thank you so much.